careful for not falling.
All right, good deal. So trig review. Let's do this.
That might help.
What questions do we have? What are the most pertinent questions? Yes, Ethan. Number 3. All right, let's do number 3. Let's do. Yeah, it's good. Okay.
8 is going to fall.
Sure. Yeah, absolutely. All right. So this is a graph. This is from one of the homework assignments you got back. So you should have the answer on that piece of paper as long as you did it correctly, of course. Tangents of x. I can't really graph unless I have a reference point to sine and cosine. So how can tangent be defined?
Sine of cosine.
Great, awesome. So that's the sine of x over the cosine of x. Okay, now remember, we get these graphs from the unit circle.
Nikki?
On the unit circle, we have a couple of points that are really nice. Why are these points nice?
Because they're zeros and ones.
Yeah, I don't have to deal with crazy fractions and radicals. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay. And I can easily find the sine and cosine at those. So like, what angle is this?
93.
Yeah, pi over 2. What angle is this? That's a pi. What angle is that?
3 pi over 2.
Good. Now, I'd really rather not draw the entire unit circle. I only want to draw things that benefit me. So if I think of the tangent as the sine over the cosine, ones and zeros are easy to deal with. So like, for instance, if I want to say, what is the tangent of 0? Well, the tangent of 0 is the same thing as saying the sine of 0 over the cosine of 0. What's the sine of 0? The sine of 0 is the y coordinate at that angle, so that's going to be 0. What's the cosine of 0? 1. What's 0 divided by 1? Oh, 0. So that one's easy to do. So I know that if I plug in 0, this is being very touchy today. So if I plug in 0, I get 0. So that point's on there. That's easy. That's easy. Okay. Now let's try pi over 2. Okay. What is the sine of pi over 2? 1. What is the cosine of pi over 2? Can I divide 1 by 0? Absolutely, positively not. No. None whatsoever. So that means at pi over 2, I have an asymptote. Which means probably at negative pi over 2, I have an asymptote. And at every odd multiple of pi over 2, I have an asymptote. Because if this is at 0 and this is at pi over 2, if I go to pi, let's see what happens. What is the sine of pi? 0. What's the cosine of pi? -1. 0 divided by -1 is 0. Oh, so I see that it alternates, right? I have a point on the x-axis, I have an asymptote. Point on the x-axis, asymptote. But the asymptotes only happen at every odd multiple. So like at 1 pi over 2, 3 pi over 2, 5 pi over 2. That's really important for when we talk about domain and range. Now, I really would like another point here. So think about the unit circle. I have a couple other points. I have like a half comma radical 3 over 2, radical 3 over 2 comma a half, and I have radical 2 over 2 comma radical 2 over 2. Which one of those points is the easiest to deal with if I have to divide two of those fractions?
Radical 2 over 2, radical 2 over 2.
Yeah. So if I'm right here at pi over 4, if I'm right here at pi over 4, I have radical 2 over 2 comma radical 2 over 2. So at pi over 4, the sine of pi over 4 is radical 2 over 2. The cosine of pi over 4 is radical 2 over 2. If I divide something by itself, I always get the number 1. Even if that thing is really crazy, like a radical 2 over 2 divided by radical 2 over 2. So that means then that I'm going to go here at an angle of pi over 4, midway between these two. That gives me a value of 1. I really would rather not do that mental math in my head, so let's make some educated guesses here. What's it going to be at negative pi over 4? Negative 1. And there I have my tangent function. It just repeats. Each set of asymptotes gives me this little curve that looks like a cubic function almost. Asymptotes? Yeah, I spelled it wrong for the first 3 years of teaching. Yeah. And then I was like, man, that's really dumb. Why would they make a word like that? I was like, oh.
Everybody makes mistakes, Mr. A.
You know, let's real quick, because this is going to be beneficial to us, talk about domain and range very quickly. Let's talk about the range first. What's the range of this function? All real numbers. Goes all the way up forever, goes all the way down forever. So the range is all real numbers. The domain is the tricky part. It incorporates every x value except for what kind of x values?
The one that are pi over 2.
Yeah, where I have asymptotes, which is where I have odd multiples of pi over 2. Okay, rewind. I have 2 ways of defining a number. 2n and 2n plus 1, where n is an integer. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Which one of these 2 things gives me even numbers?
The top one.
The top one, because 2 times anything is even. Which one then gives me an odd number?
The other one.
This one, because an even number plus 1 is always an
Odd number.
odd number. So this is like our mathematical definition from Algebra 1, which you may or may not have gotten, on the definition of an even number and an odd number. Now, can n be a fraction?
No.
N has to be an integer. So I say that these things are true if n is an element of integers. And we use the letter z to represent the word integer. So when I talk about this domain, it's actually relatively complex. I want to say in words that every odd multiple of pi over 2, I do not have an x value. So let's go ahead and do that with respect to the definition of an odd number. So here's what I'm going to do. Every odd means 2n plus 1. Every odd multiple of pi over 2. So I multiply this by pi over 2. Every odd multiple of pi over 2 is a restriction. I cannot have those values. So this means that my domain is all real numbers, comma, except for 2n plus 1 times pi over 2 will not give me an x value that works, where n is an element of the integers. Now, I'm going to write this in a little bit more meaningful of a way, but I want you to see me kind of break it down, right? So I know that every number works, except for these odd multiples of pi over 2. So here's the appropriate way now we're going to write this domain. So I'm going to say the domain is negative infinity to infinity, comma, except that x cannot equal numbers that have this form. 2n plus 1 times pi over 2, where n is an element of the integers. That might be a pretty darn good extra credit question on the test if you remember that domain.
Well, I want
Hint, wait. So that means every number works except for numbers that are odd multiples of pi over 2. Yeesh? Fine. All right, good deal. Other questions? That was a nice, nice email. Other questions?
Number 12.
12, love it. Is that graph?
No.
Oh, good. Oh, okay, sure. Yeah. All right, so number 12 is like the demanda del Giorgio's we've been doing. So tell me, Charles, what is it?
Sine of arc cos of negative radical 3 over 2.
Okay. So let's remember back to our demanda del Giorgio's. What's the first step?
Take the sine part.
Theta. Theta equals this stuff. So we're going to say, let theta equal this arc cosine of negative radical 3 over 2. If we do that, that means that this problem changes to just finding the sine of theta. Okay, now what's the next step? Yeah, you could just skip right to the triangle, and that's cool with me. You do not have to show me that you take the cosine of both sides. I'm going to, because some people like steps. But you can skip to the triangle if you want to. So I'm going to take the cosine of both sides. What happens to the cosine and the arc cosine?
Cancel.
Cancel, good. So I have the cosine of theta equals negative radical 3 over 2. And now I could do a triangle. I could. Or I can realize that radical 3 over 2 is on the unit circle. That's the easier route because it requires no work. So I'm thinking to myself, on the unit circle, what angle gives me a cosine value of negative radical 3 over 2?
5 pi over 6.
Or 120.
Let's think about it. Yeah, negative radical 3 over 2. So that means that I'm going to be at pi over 6. Because, oh no, not even pi over 6. Yeah, it's negative. So negative radical 3 over 2. That means I'm going to be at 150, which is 5 pi over 6. I'm also going to be here at 7 pi over 6. Because both of those have coordinate points that's negative radical 3 over 2, comma, something. Now remember, in the first part, I'm dealing with the inverse cosine. We have limitations to our inverse functions. What is the limitation for inverse cosine? The top half. Perfect. So it's 0 to pi. So which of these two options is in the top half, which is 0 to pi? 5 pi over 6. So I can say from this actually, I can skip the whole triangle piece and say, hey, listen, theta is actually 5 pi over 6. Theta is 5 pi over 6. So if I go now to this function, I'm saying, okay, what's the sine of 5 pi over 6, and what is it? What's the y coordinate at that point?
1/2.
1/2. Learning moment. We did the unit circle last semester. Is the unit circle still important?
Yes.
Yes. Will the unit circle always be important?
Yeah.
Yes. When you go to your next math course, we probably need to know the unit circle.
Yeah.
Yes. So please, for the love, you didn't have memorized. Have memorized.
Oh. Me
No. So 1/2. The reason why we have that triangle method, everybody, is when I don't have a special number here. So if this were something like 3/4, or something like 5/7, or radical 19 over 5, that's when I have to use a triangle because there is no special angle for that. I would have to go to like a trigonometric table to find values. So that's when we use the relationship piece. Good question, Charles. All right, other questions? Yeah? 6, you said? Good. Graphing one.
I swear I'm a
Graph following with.
never have you.
Hey, I'll be honest with you all, there is probably going to be, I don't know, one graph on the entire math portion of the test.
Nice.
Because it's not going to be tangent. Because it is very, very involved. Now, you will still need to know the basic sine and cosine graphs. You might have to recreate those for me. You might even have to recreate the tangent graph for me. But I will only ever give you one graph that has transformations. Okay? So for number 6, it's
3 cosine.
3 cosine. And here, I'm going to actually pause this and do it again.